Today, I will be demonstrating how to use a color meter to generate a Beer's Law plot. Now, to conduct this experiment, you'll need to gather these few essential equipment: a color meter, digital meter, 2 test wires with probed ends, 2 color meter wires with alligator clip ends, a plastic tweezer, and test tubes filled with already prepared solutions with known concentrations of the analyte. With the digital multimeter that is turned off, place the end of the red test wire into the VOHM-MA slot and the end of the black test wire into the COM slot. Attach an alligator clip to the red wire's probe and another for the black wire's probe. Afterwards, with the color meter turned off, connect the other end of the alligator clip wires to the hole of the color meter. Match the alligator clip attached to the red wire to the red hole and the black wire to the black hole. This is the final assembly. Keep in mind that we will measure all the solutions under the same wavelengths, the reason being that the dissolved solutes might absorb more or less for certain wavelengths. Thus, we need to keep the wavelength consistent so that we know the amount of light absorbed is due to the concentration of the solution and not the different wavelengths. We are now ready to start the test. Next, turn on the multimeter power by dialing it to 200K in the ohm section. Turn on the color meter as well by moving the switch from the off to the red, which will produce a red light. You will then need to remove the cap from the color meter chamber and use plastic tweezers to gently place the test tube into the chamber and place the cap back on it. The multimeter will then display the electrical resistance of the sample in ohms. Wait for the reading to stabilize and record the resistance. Finally, remove the cap from the color meter chamber and use the tweezers to remove the tube. Repeat these steps for the other solutions. Once all the resistance measurements are taken, you can utilize this equation to solve for the absorbance value. With the known concentration values of the analyte and the absorbance values of those concentrations, we could create a Beer's Law plot. Concentrations would be on the x-axis and absorbance on the y-axis. Next, add a line of best fit to the graph and display the equation for the line of best fit. This is all the steps you need to take to use the color meter to form a Beer's Law plot. That is all that is needed to generate a Beer's Law plot. But before we end, the lab members in this group are Sarah Choi, Matthew Kyritz, and Anthony Park. While Anthony worked on the script, Sarah worked on the research and recorded a demonstration, and I, Matthew Kyritz, helped edit the video.